Welcome back to Aurora Tech Channel. This year, there have been many 3D printers flooding the market, most of them being Cartesian bed slingers. Personally, I prefer to have a box frame with CoreXY kinematics as it provides smoother motion on the X and Y axis and a more stable Z axis compared to a bed slinger, as its print bed only has to move up and down. Today, I will review the Flying Bear Reborn 2, which is the CoreXY with linear rails on the X and Y axis and linear rods on the dual Z axis. The timing belt on the CoreXY axis is 10mm instead of the regular 6mm you see on most 3D printers, and all stepper motors on the X, Y, and Z axis are 0.9 degrees instead of the standard 1.8 degrees. The print volume is 325 by 325 by 350 millimeters, and it has a dual gear direct drive extruder with a 1 to 7.5 gear ratio. The maximum nozzle temperature is 350 degrees Celsius, it has a dual part cooling fan, and it uses an AC heated glass bed. It's a fully enclosed printer with 3 plastic boards on all 3 sides, a set of acrylic doors at the front, and an insulation tent on top. It runs an MKS Nano 6 motherboard with TMC 2209 silent stepper drivers, a 3.5-inch touchscreen, and inductive limit switches on the X, Y, and Z axis. Flying Bear claims that this printer can print at a maximum of 150 mm per second with a normal printing speed of 80 mm per second with 1,500 mm per second squared acceleration. Overall, for around $500, the specs of this printer look pretty good. I would like to thank Flying Bear for sending me this machine to review, and with that, let's get started. We have quite a lot of parts here, including the heated bed and the bed frame, the base, the extruder, linear bearings for the dual Z axis, a filament sensor, a filament holder, some T-nuts, screws, and tools. We also have 4 20 by 20 aluminum extrusions, the top frame with the CoreXY belts and stepper motors pre-assembled, 4 linear rods, 2 lead screws, 3 plastic boards and 2 acrylic doors as the enclosure. I will put 4 sets of T-nuts on each corner and use them to secure 4 20 by 20 extrusions to the base to form the frame. Flip it over and install the adjustable legs. Then, install 2 sets of T-nuts at each corner of the top frame. Then, align it with the frame and secure all corners using the T-nuts. Install the rounded end caps at each corner. Connect the cable from the top to the base and hide the wires inside the T-slots. Install the couplers of the lead screws and mount 2 sheet metal brackets on the bed to trigger the Z limit switches. Next, install 4 linear bearings and the linear rods with 2 on each side. Install the lead screw, the anti-backlash nuts, and secure the lead screw on the coupler. Do the same to the other side. Then, mount the print head on the X-axis carriage plate and move the bed up by turning the couplers so you can see the cable connector. Install the plastic boards on the side and mount the filament holder and filament sensor on the right side. Install the board on the left side and the one at the back. Finally, install the acrylic doors, and we are done. In total, it took me a little less than 2 hours to finish the assembly. We can now go to the computer and set up this printer in Cura. Since this printer is new and there is no existing profile in Cura, you can select Ghost 5 and download the print profile and the start and end G code from the support website to manually create the profile for this printer. As I have other printers that use the MKS motherboard, I already have the MKS Wi-Fi plugin installed. You can just enable Wi-Fi and type in the IP address of the printer. You can also enable the preview thumbnail feature so the screen will show a picture of the print. If you don't have the MKS Wi-Fi plugin, you can search MKS and download it from the marketplace. Okay, let's start with the calibration cube. I will use the standard 60mm per second profile, upload the G-code file to the printer, and start the print. The cube looks pretty nice. The layers look good, and there are some minor flaws on the surface which were probably caused by the retraction settings, as by default, the retraction distance of the print profile is set to 3mm, but for a direct drive like this, using 1.5 to 2mm should be enough. When I measured the cube, the X and Y axis are accurate, but the Z axis is around 2% taller than expected, so I will download the firmware source code from the official website and adjust the Z axis step value. Open configuration.h, search for steps, and change the Z steps from 800 to 785, which is 98% of the original value. Compile the firmware, go back to the .pio folder, and copy the Robin Nano 6.bin file to the micro SD card. I also downloaded the latest screen assets, and I will copy the folder to the root of the SD card. Then, turn on the printer to update the firmware. Okay, we can now reprint the calibration cube. As you can see, the cube is now slightly shorter than the previous one. When I measured it again, the X, Y, and Z axis all look good. Next, I will print a 3D Benchy. There is a bit more stringing than what I would have preferred, but overall, the layers, overhanging, and cooling look good. Then, I will print some Ikea LACK end table risers. These risers are used to stack 2 end tables together for my 3D printers. Since they are functional parts, I can just set the layer height to 0.3mm. If I use the standard 60mm per second profile, it will take nearly 7 hours. Let's try the 150mm per second profile, where the travel speed and infill printing speed are set to 150, the inner walls are set to 40, the outer walls are set to 80, and the first layer is also set to 40. As for the acceleration, most of them were set to 1500, but I don't think setting it to a higher number will make a difference, as the maximum acceleration in the firmware was set to 1500. Let's slice it, and it will take just around 4.5 hours. For your reference, if we printed the same model using an Ender 3, Ender 3S1, or other standard 3D printers, and set the layer height to 0.3mm, it would take around 9 hours to print. So let's print with the 150mm per second and 1500mm per second squared acceleration and see how it looks. The print looks fine, and I can't see any problems with these risers. I haven't installed them yet, but they should look just like the red one I printed with the same voxel PLA filament. After that, I will use some wood-filled PLA to print this model of Groot. This filament strings more than regular PLA, so we just reduce the nozzle temperature to 205 to 190 to see if it will string less. The model turned out beautiful, other than some stringing at the bottom, and after the temperature is set to 190 degrees Celsius, it looks perfectly fine. The details on the back and the sides all look good. Then, I will print a headphone holder with $12 Eryone PETG filament. This print also looks nice. The layers are fine, and the top overhanging part has no issues. The glass bed sticks to PETG well, and there is no sign of warping at the corners. Next, I will print a challenging model and print this crate using ABS. Generally, I would apply glue to the bed when printing ABS, but I will try printing directly on the glass bed and seeing how it sticks. After the bottom is finished, there is a tiny bit of warping at this corner, but I think it should still be fine. As my garage temperature at night is around 16.5 degrees Celsius, the enclosure should help a lot when printing ABS. As you can see, the temperature inside is around 43 degrees Celsius, which is 26 degrees Celsius higher than the temperature outside, so it should be able to prevent layer cracking. The print is not perfect, with some warping at the corners, but the layers didn't crack like the black one that was printed by an open printer. Then I will try printing with some TPU. I will print a 4-leg protector from my Ikea end table. The result is okay, but I wouldn't expect for there to be any issues with this simple model, as this direct drive, as well as my other bonus setup printers, should be able to handle this filament. Other than a tiny bit of warping at some of the corners, the parts are functional. The maximum nozzle temperature of this printer is 350 degrees Celsius, which is more than enough to print nylon carbon fiber and polycarbonate, so I will print a cable roller with PA12-CF. I applied some glue on the bed, as nylon only sticks to itself and glue. The top part of the roller looks okay, considering that this roll of nylon carbon fiber filament hasn't been dried ever since I opened it 2 to 3 months ago. I will then print the bottom. These areas are not printed very nicely, which is probably because of the moisture in the nylon filament, but the part still fits perfectly. I will print the same model again using polycarbonate. Since this material requires a 300 degrees Celsius nozzle and the 110 degrees Celsius heated bed, I will also apply glue and let the printer be fully enclosed. The first part was finished without any issues, so I will print the second part. They fit together nicely, and I can use it to roll up the extra long microphone cable that I use to record my videos. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The CoreXY kinematics with linear rails on the X and Y axis and linear rods on the dual Z axis, and the 10mm timing belt instead of the 6mm ones on regular 3D printers, which is nearly the best motion system you can get in this $500 price range. 2. The dual gear extruder has a 1 to 7.5 gear ratio, and the filament pushing force is strong. It's stronger than most extruders I've ever tested. The heatsink is a one-piece design with a hardened steel nozzle, and the whole hot-end assembly is pretty high quality. 3. It can handle all types of filament, including PLA, PETG, ABS, TPU, nylon carbon fiber, and polycarbonate pretty well. The maximum nozzle temperature can reach 350 degrees Celsius, which is more than enough to print polycarbonate and nylon carbon fiber. 4. The glass bed is super flat and is almost 2 times thicker than the glass beds you would see on a regular 3D printer. It sticks well with most materials, but for those tough to print materials like ABS, PCCF, and PC, you still need to apply some glue. 5. As for the print speed, the maximum acceleration of this printer is set to 1,500 millimeters per second squared. So, when it's printing at 150 millimeters per second for infill and 40 to 80 millimeters per second for the walls and the first layer, it still gets pretty good print quality. And it can print this 3D Benchy in 1 hour and 9 minutes, which is faster than a standard 3D printer like the Ender 3, printing at 50 millimeters per second with 500 millimeters per second squared acceleration, which takes 1 hour and 50 minutes. If you print something larger, like this 180 by 180 by 20 millimeters square, as it's large enough for the printhead to accelerate, the print time of this Reborn 2 will be around 5 hours and 50 minutes, while an Ender 3 or a similar printer will need 17 hours and 19 minutes, which is almost 3 times slower. 6. The full enclosure is a low-cost but effective solution. Flying Bear used plastic boards and T-nuts for the 3 sides, 2 acrylic doors at the top, and this tent style as a top cover is not the most beautiful design ever, but all parts are functional. Additionally, it's now nearing the end of October and the weather is getting pretty cold at night. So when I print ABS overnight, the temperature in my garage is around 16 to 17 degrees Celsius, and the inside temperature of the enclosure can still be maintained at 41 to 43 degrees Celsius, which is 25 degrees Celsius higher. So when your room temperature is around 25 to 30 degrees in the summer, it should be able to reach higher than 50 degrees Celsius. 7. The X, Y, and Z axes are all using inductive limit switches, which are more accurate than normal mechanical limit switches. The Z axis also has a dual limit switch, so it can ensure that the Z axis is synchronized every time you home the printer. 8. The AC heated bed heats up really fast when heating for PLA, TPU, or PACF, which only requires 60 degrees Celsius and takes 1 minute. For PETG, which requires 85 degrees Celsius, it takes 2 minutes and 10 seconds. And for ABS and polycarbonate, which requires 110 degrees Celsius, it still only takes 3 minutes and 49 seconds in my 18 degrees Celsius garage. 9. The frame is quite heavy. This printer is over 40 pounds, which is around 20 kilograms, and a printer with a sturdy frame vibrates less, so this should also improve the print quality. Now for the cons. 1. This printer does not come with auto bed leveling. I didn't have any issues with manually leveling the 4 corners of the bed, as you have to do the same thing even when you do have a BL Touch, CR Touch, 3D Touch, or other sensors. However, since this printer uses a glass bed, you may still need to use a spatula to remove the print if the part is large and flat, or if you applied glue to the glass bed. In this case, you may still have a chance to move it. If you have a bed leveling sensor, it could help compensate for that, but for this manually leveled bed, you may need to re-level it. 2. The AC heated bed is fixed onto the thick glass bed. If you need to replace it in the future, it will be very challenging to remove the silicone heated bed underneath without damaging it, so you may need to replace the heated bed altogether. Since the size of the bed is 330 by 330, it's not a regular size bed that you can easily find on Amazon or AliExpress. So to replace a silicone heated bed and a glass bed would cost around $130, which is not cheap. 3. The top of the cover of the enclosure is a tent, which kind of works, but the extra space between the top of the printer and the top of the tent is unnecessary, and it would trap the heat better if it wasn't this tall. The tent itself is black, and it has black plastic boards on the sides and back as well, so it'll be completely dark even if your room has lights on. As the inside of the printer does not come with any LEDs, my solution was to stick a LED camera light outside the acrylic doors to film the printing when you need to have the printer fully enclosed. In my opinion, using a transparent acrylic top would be much better. 4. The ESP8266 Wi-Fi module is slow as it communicates with the serial port of the motherboard to transfer data. If you just upload a 3D Benchy or Calibration Cube G-code, it will be complete in seconds, which is totally acceptable. But if your G-code file is large, like 30 to 50 megabytes for a complex model, it will take a few minutes and you would definitely want to copy the file to the microSD card instead. This printer uses a maker-based motherboard with the MKS 3.5-inch touchscreen. The hardware of the motherboard itself is alright, but MKS firmware and screen firmware has always been buggy from the time I first saw this motherboard a few years ago. It has different minor issues with almost every machine I have tested. On this Reborn 2, it allows you to set the preheat temperature to as high as you want, which looks scary, but it does trigger the firmware's max temperature warning and will stop the printer once it reaches the maximum temperature. I have also changed the stock maximum temperature from 500 degrees Celsius for the nozzle and 150 degrees Celsius for the heated bed to 350 degrees Celsius and 110 degrees Celsius. So it just looks scary, but it won't cause any actual damage. 5. The magnet on the acrylic door is not strong enough. I simply added another stronger earth magnet on top of the stock magnet and it works perfectly fine. 6. The assembly takes longer than a regular 3D printer, even when compared to a box frame printer like an Ender 5 Pro and Ender 5 Plus. It uses many T-nuts, so more work is necessary to put it together. But the good thing is, you can align the frame as perfectly as you want, as there are no threads drilled on the extrusions. It took me around 2 hours to put the printer as well as the enclosure and doors together. In conclusion, if I'm going to build a CoreXY with linear rails, linear rods, and an enclosure with the same hardware, I would not be able to make something like this for just $500. The build quality and the hardware are really good. The print speed is fast, and the print quality is also okay on different materials. And though the maker-based motherboard is a little bit buggy, it is still functional. If you install Clipper firmware on this Reborn 2, I believe it can easily print up to 250 mm per second with 3000 mm per second squared acceleration, as the linear motion system, extruder, and part cooling are all good. So, if you are interested in this Flying Bear Reborn 2, I put the link under the description. That's it for this video. If you like this video, please hit the like and subscribe button and click the notification bell to receive new video updates. I will see you next time.